Okay, so now we're gonna talk about problems. You have no hot water. So what does that mean? You don't have any water at all that's hot? Well, if so, you gotta make sure that the valve is open, obviously. The other thing is, do you have electricity? Well, you may put your tester here and you feel, you hear it sound, but maybe one of them is on, one of the breakers are on, the other one is not on. So you have to make sure both breakers are on. Now, what if one breaker is off? Then you have an electrical problem. So you need to actually go talk to an electrician and find out why it went out. It may happen once every while. But it happens too often. That may mean that you have a short, and you don't want to mess with electricity. If the breaker goes off when you're under the shower and there is water coming all over you that's going through the system, so again, bad for your hair. You're gonna get a bad hair day that day. So if you have problems with the breaker going off, it's possible somebody attached other wires to that breaker, use it for something else which shouldn't be that way, or there is actually a water leak somewhere that causes this, or there is a short somewhere in the wiring. So I would say just leave it off and call an electrician for that. Don't mess around with it. Second thing is, all right, you have a little bit of water coming, but it's cold. Well, here's the thing. I told you that this is a sensor. If it does not detect much of pressure going through, it doesn't even turn on. So you have to have a certain pressure for this to actually send the message to the thermostat or to the brain and say, hey, there is enough water coming in, we need to turn on. So if you just open your faucet, just let it drip a little bit, it's probably not going to turn it on because there's not enough pressure. Now, since I'm talking about pressure right now, there is another problem, a code E5, and I'm going to show it to you in a second. Okay, this is a 1/2 inch unrestricted water flow. I'm going to turn on this thing right here. There is a little bit of water in there, but not much, but because we shut off the hot water heater input, but I'm going to turn it on in a second, but I just want you to see. Okay, I made sure that there is no water on the wires, or else I would have wiped it off. There was a little bit of water here, but that's nowhere near this, so that's good. I turn on the two breakers. Now I'm going to turn on the thermostat. Obviously, all of this has electricity. I don't want to touch any of these wires anywhere, so I've got to be careful by pushing here. It's plastic, so it's not going to give me a shock. If you don't like it, you can use your knob, put it back in there, just push it in. All right, off, on 140. Okay, it's on right now. Nothing is working because there is no water flow, obviously, because I shut off this valve that goes inside here. So let me turn this off for a second. I'm gonna turn it on. No, as I'm turning it on, I'm gonna turn it on slowly to see what happens, because once I fully turn it on, there's a lot of water going through, and that's going to cause a problem. It's going to give you a code. So turning on a little bit. Okay, it turned on. It says 114. Well, it wasn't enough. Oh, actually no, it's turning on, so it just goes away. It turns on for a second, then it goes away. Let's see. I was wrong. I had this other valve closed here, so I'm going to turn this back on. That's the outflow of hot water. All right, now this valve is attached to that 1/2 inch pack that I showed you. So I'm going to go ahead again, turn this on a little bit. Okay, and you're going to see that it's going to turn on. Okay, it's going to turn on. It's gonna heat up on here. It's gonna heat up, so there's gonna feel warm. Don't touch, please. There's a reason I touch it. It's getting hot, but this is only partial open, so we don't have the full pressure. I'm gonna go ahead and turn it up all the way, see what happens. Code E5. I'm gonna turn it off. Okay, it stopped. Why code E5? Because there's excessive flow of water, and this water heater does not have enough energy or heat exchanger to heat up all that excessive water flow. And so at some point it says, you know what, I cannot heat up all this water, it's going too fast through me, so therefore I'm just going to shut off and give a code. And that's what happened. So if you have one of these little water heaters at home and you have two people taking shower at the same time, or one person is taking shower and then the washing machine is on hot, then this is what's going to happen. It shuts down just because it cannot carry that much water through and heat it up. So that's what E5 means. Okay, so we talked about one problem. What if you have and code E5, but we're still talking about not having much hot water or not enough. Another reason for not having enough hot water is there is a what's it called, a filter in here. It's actually between here and right there, and that filter with time it could go dirty, and it doesn't allow enough flow going through. If it's just a little bit of flow, so you're gonna have a little bit of hot water coming out, not much. And so if it's not much of flow at all, again the same thing, it will shut off because it doesn't sense much flow and it doesn't want to turn on anything. So basically in this case you have to obviously shut off the water, shut off the electricity again, open this union, open this right here. Let me show you. There's union here. Open that, hold on to this, open this, open it from here, and then they actually pull out by itself. Clean the filter, and after that it should work well. If you have hard water or well water, you might want to consider putting a filter out here so it filters it before it goes through. In my case I did something else. If you see, this is crazy, this is what I did actually. So basically I don't want to open it. I did it one time, I don't want to do it ever again. So I actually put in a system that I can, by turning some knobs here, I can have it clean itself. Basically what I did is I added this right in between the inlet and the outlet, and then added all those valves, added drainage right here. So right now the cold water comes in this way, goes up, gets heated up, comes up, comes down, goes down this way. It cannot go that way because that's shut off. Now if I want to clean this, I'm going to make sure that the water goes backwards, because all the sediment and everything else is stuck this way. Once I get the water going in that way, it will actually push it out, but I don't want it back into my water system. I want it outside. So that's why I have this drain. This drain goes all the way down to the bottom of the house, and it goes away. So basically what I do is I shut off this like it is right now. I shut off this one. So this is the inlet water that goes to the water heater. This is the outlet. I'm going to shut this off. Now the water cannot go up here, but it could go this way if this is open. So I open this. Oh, before doing this, by the way, you have to push the button until it says off, because you don't want this to happen while the water is on. The computer doesn't understand why everything goes backwards, and it may cause problems. Don't do this if you don't know what you're doing. For me it works out. So anyways, you turn that off. You turn off this water heater, but the valve that's below it that takes the water from inlet to the outlet, that I turn on right now with this closed. Okay, so water cannot go up. Water comes here, goes through if this is on, and because I turn this off, it cannot go to the rest of the plumbing, the hot water plumbing of the house. It could go only up. So it can go this way backwards to the water heater, but it needs to go somewhere. So I added this drainage right here, open this, and then it goes down. So I let it flow like this for about 30 seconds, maybe 1 minute max, and it should clear up anything that's as far as the sediment and stuff like that, anything that is in the filter, and that take care of some problems. Anyways, I don't know if you can see all of this. Inlet valve, drainage that goes down, inlet to outlet, kind of. There is a valve below it, not over it, below it. So this gets shut off, this gets turned back on so it can drain, this been turned on so it can go backwards, and this must be shut off so it cannot go that way. It has to go this way out. I'm sorry about the background noise. We had a train passing by. Anyways, so that's one thing you could do. Now, what else could go wrong? So I had a little bit of warm water, but not much. I found out that one of the coils were bad. Not both of them, one of them. Can you guess which one? Obviously it's this one, because it turns on and off all the time, depending, it doesn't matter how much hot water you're using, this is always going to turn on. This one turns on only if there is a lot more water going through, and this one cannot heat it up all the way. So how did I find out? Well, here's the thing. I used electric meter kind of thing like this. You put it on you want to measure for 240, so I put it on 750 AC. All right, then I took the leads. One lead goes right here. Well, actually, yeah, let me see, give me 1 second, let me figure. Okay, I figured it out. So if you look at the wires, each one of them goes to a different set. One of them goes to this set right here, this pair, the other one goes to this two. So I got to figure out which one is which. So anyways, this is 240, this is 240. So what you need to do is you take for this one goes up right here to this one right there. Okay, you're gonna put one end here and one end on top. You gotta be careful. You have 240 volts going through this, so please don't do it if you don't know what you're doing. So one on this side, one on that side. I did this one, actually I did this one first, and I would get 240 on each side. That means it's going through. When I got to this one, I used the other pair, obviously. When I got to this one, connecting one side to this and one side to that, on one side it said 240. That means it goes to one side. On the other side it said 90, and I'm like, why is it 90? That means somewhere inside the coil is no longer connected, therefore it cannot heat. So it could be 90, it could be maybe almost zero, it could be something else, but it has to be around 240. So whatever you measure here, if I put these two, both of them here at this two, it should be about 240. Now plus minus 5 volts, if you have 235, that's fine, but if you have like 150, 160, there is something wrong with your electricity. You gotta talk to an electrician or talk to your utility provider. So anyways, if you have from here to here 240, and from the same place to here still 240, that means you have electricity current going through this coil. This coil should be okay. But when I got to this one, the first one that always turns on as soon as you turn on any kind of hot water, no matter how much it is, if it's little water or more water, that one showed a different number. It wasn't 240 as it was with the other one, or 242, whatever it was. So I knew there was something wrong with that. So guess what? I could not find anything that I could purchase by going to Home Depot, Lowe's. So I ordered it on Amazon, and I said, okay, until I get it from Amazon, it's going to take like 3-4 days, and I don't want to get cold showers. So what I did is I turned off the electricity again, pulled this out, pulled that out, put this one here, put this one here. The one I have here right now is actually the secondary coil. It's still kind of good. So to a certain point, it actually makes everything hot. When you use a little bit more water, because this one doesn't work anymore, it doesn't give me the heat that I had before. So obviously this is just temporary, and I had to do it because I didn't want to wait 3 days and take cold showers until I get my 2 coils. So that's how you do that. You open up, you shut off the electricity again, you put your wrench right here and pull the whole thing. You got to pull your hand on one side to support it. It comes out. The same thing with this. Obviously you have to have the water shut off as well, and depressurized. So you shut off the water right here, and you turn on the faucet, or in my case I can turn on the drain right here to depressurize it, still you're gonna get some water coming out, and that's why you need to make sure there is no electricity hooked up to this. And later you have to make sure everything is dry before you hook it up to electricity again. What are these? I believe these are sensors. If this coil overheats for whatever reason, it gets too far up as far as temperature, these things are going to shut off the flow of electricity, therefore it will not heat up anymore. Okay, again, that should never happen. If it, I mean, how often will it overheat unless there is a problem? But if it does, it momentarily turn off. Once you shut off the water, this turns off, turns back on, it should reset. If it doesn't reset and it actually goes out for whatever reason, just because it malfunctions or it really got hot and it got damaged, the way you find out if it's working or not is if you have between here and here 240, then this is working. But if you don't have 240, come down here, check this. Between this and this, you have obviously just a wire, you still have 240, but once you put it on this side of it, so again, one side here, the other side of the voltmeter right here, then if you don't have 240, that means this part right here is not working, so you have to change that too. It's some kind of heat sensor. I forgot what it's called. They don't go out that easily. So anyways, in order to change these, obviously, first thing you do is shut off the electricity, test here to make sure there is no electricity, shut off the water again, open a faucet somewhere on the hot water side, not the cold water, just the hot water side, just to depressurize it, and go ahead and open it. You have to open the screws right here. Phillips screws. There are 4 Phillips screws. You have to open them. I marked them so I know which one is which. So I put 2B, 2B, well actually 2A, and then this is 1B, and I put 1B here so I know 1B goes on that side, 2B here. Actually it doesn't matter as long as these 2 wires come on this side and these 2 wires go on that side. It doesn't matter which way, but I want it to be the same exact way. So you may want to take a picture from before and after. Obviously you tighten it as much as it needs to be tightened in order to not leak. Let me show you how the new part looks like. Okay, this is the new part. It comes with a gasket right here. The gasket goes around, and I think I paid for 2 of them, a pair of these for $40 from Amazon, and this is 9,000 watts. I'm not sure if you can see that or not. Oh, you can, but take my word for it. It says 9,000 watts, which is 9 kilowatt. So yeah, you search in Amazon 9 kilowatt or 9,000 watts or 9 kilowatt, and it's gonna come out, show to you what they have. Yours may be different. Some of them are only 1 coil going down. It doesn't turn back up anymore. You have to open yours in order to see, and you have to make sure